Well, greetings out there in YouTube land and welcome to today's video. Recently I was approached by a viewer and asked if I would repair their Fender amp, and to save money I had him send just the chassis and the reverb tank. And now you're wondering what type of Fender chassis travels in a box this size and weighs close to 50 pounds. Okay, if you're as curious as I am to see it, let me set down the camera, open the box, and we'll check out what's inside. Well, first off, I've got to say that this gentleman could give lessons in how to pack amplifiers. Look at this. Everything is surrounded by foam with inlets for the reverb tank, a tube set, a letter here of instructions. This is probably, yep, a giant schematic. And when I say giant, I mean it. You could use this for wallpaper. Okay, let's get all this laid out and see what we got. And now, lo and behold, after unpacking all the miscellaneous accessories, we see a 135 watt Fender Twin Reverb. From the top here, it looks pretty darn clean and nice. Okay, we'll go through the letter and discuss what's wrong with it, and we'll check out the parts that were sent, and then we'll flip it over and get started. And to get this out of the box, it's probably going to take an engine hoist. I don't think I've ever seen a power transformer any bigger than this one, or an output transformer. Absolutely incredible. This is probably where 40 of the 50 or so pounds of weight is located, right here at this end. Alright, I've laid everything out here on the workbench. Of course, the chassis, the old tube set, and look at that. Talk about a mismatched set of 6L6 GCs. There's no two that are even remotely alike. Okay, a set of original, the smaller tubes, 12AX7s, no doubt, maybe an AT7. And here is a new tube set. The original reverb tank, we'll have to test it to see if it's still working. The reverb cables, and a fuse holder. And a monster schematic, suitable, I guess, in dimension and scale to the amp itself. This should be easy on the old eyes to read. And we also got a letter that describes the problems with the amplifier. Let's take a look at it. Okay, let's go through this quickly. The amp comes from 1978, obviously a Silverface. It must have been used in some disco punk band. Lots of burn marks, wax covering the insides, maybe from melted capacitors or transformer insulation, the potting. Also, there was a marijuana cigarette inside. I'm glad the drug-sniffing dogs at the airport didn't pick up on it. Now, apparently, he fired it up, literally, set the volume to 5 and strummed an E chord, and pretty much demolished his house and his relationship with his neighbors. I'm assuming this thing may even be louder than a Marshall amp. There is a horrific hum. Okay, he tried to bias it, and the hum persisted. Naturally, we're going to be thinking of electrolytic capacitors when we hear a hum, depending on the frequency, 120 hertz, and we'll be thinking electrolytics. 60 cycle, and it's every man for himself. There's about 900 different reasons. Okay, so that's about it. Let's go ahead then and get started. We'll put all of our miscellaneous parts to one side. Let's take a look in the doghouse and see, and if we're looking at a whole set of brand new Mallory filter caps, then that's going to kind of shatter my theory about electrolytics being at fault. But let's clean things up and then take a look inside the doghouse. Oh, and one more thing before I get started on the dismantling. He wants the master volume control removed from the circuit. Okay, that's kind of the downfall on any of these later 70s large Silverface amps is when they started putting master volume controls in them, the value of the amp just dropped precipitously because people just don't like it. Okay, it's like if Harley Davidson started to sell a steam-powered motorcycle or something, people just aren't going to accept a whole lot of fooling around with a classic circuit. Okay, so he wants that removed. Naturally, once it's removed, this won't suddenly double in value, but I guess he feels it interferes with the use of the amp, and so we'll remove it. Any of you who would like to join in that, then we'll see how I do it on this one, and it might help you if you choose to remove the master volume control on yours. If Jack is in the mood, he's going to demonstrate one of his greatest tricks for us. Apparently he's not in the mood.
Go, Jack.
Good boy, Jack. Where is he now? He's vanished. Where's Jack? Well, I think the chances of any speedy, easy repair just went out the window. When we look in here, and the electrolytics have all been replaced with F&Ts, and a couple Asian caps here, which are just fine in my book. So unless one of these is installed wrong, which I'm going to check right now, I think we can pretty well eliminate electrolytics as the source of the problem. Also, it might be a good idea to test each one of these to make sure that it is fully functional. Sometimes new ones aren't. It's very rare. I almost never see it anymore, but you never know. I'm pleased to report that that serious hum problem was quickly and easily resolved simply by using the output tube hum balance control right here to balance the two pairs of 6L6GC output tubes. As many of you know, one of the big advantages of a push-pull circuit is that the two out-of-phase output tubes tend to neutralize any hum that might be presented to them by the power supply. This is why you're able to get away with sending relatively unfiltered B+ up here to the plates of the output tubes. I don't know if you ever wondered about that, because this really is not well filtered B+ at all that's being sent to them. But it's not an issue normally because the out-of-phase tubes will neutralize that hum. But if the pairs in this case, or single output tubes in most cases, are not balanced, then there is a differential between them of hum that is actually amplified. So it's essential that you, especially with 4 output tubes like this, that you balance the pairs. Alright, the amp is functioning. You can hear the signal generator tone in the background, but we've got a serious problem with microphonics. Listen to this. Hear that coming through the speaker? This one to a lesser degree. Bad. Listen to this one. Virtually nothing. Nothing. See, normally tubes are just not going to make noise through the speaker when you tap on them, but this one has some serious problems. Now, what can you do about it? Actually replacing the tube or putting the tube in a different location may help. Okay, but it's an internal problem with a tube that you cannot solve externally. And in this case, it's really serious. Look what happens when I tap on the table. Hear it? Kind of an echoey sound in the speaker. This tube's got a problem. Alright, let's flip the chassis over and take a look at the circuit itself. You can see down here in the power supply where you have your full wave bridge rectifier. And looking at the eyelet board, it appears that every single nonpolar cap and electrolytic has been replaced. Okay, now that's a mixed blessing. If it was done properly, great. Okay, and it looks like good quality orange drop caps. But if it was done improperly, then the nightmare begins at trying to hunt down where the mistake was made. Now this is why unmolested amps are always much easier to work on. You can assume that when it left the factory it worked. Therefore, even if you have a faulty component, at least it's the right value and in the right place. With an amp like this, it's been worked on a great deal. There are no guarantees in that regard. I think step one will be to clean all of the potentiometers. I've noticed all kinds of problems with the volume control, where you'll get volume at 1 and then no volume at 2 or 3, things like that. And I think the pots are probably filthy, and the tube sockets probably are too. So let's clean all the tube sockets, all the pots, and eliminate that as a source of error. Once I started cleaning the pots, it became evident that every single one of them has been replaced. These all appear to be brand new potentiometers and knobs, all except for the master volume control, which is the old dingy pot with a switch on the back. You can see the difference. These are all brand new. That just exacerbates the problem, because now I have to check that every one of them is wired correctly, that every one of them is of the right value. Okay, this looks to me like just about the worst possible nightmare for a repair person, in that you really have no basis upon which to start, because you can't trust what's here. Okay, this amp has all sorts of issues. Now when you get one like this, which has had extensive work, and yet they still send it to you, that means all of this didn't solve the problem. Whatever the problem is, it's up to you to find, and God help you. Okay, so this is why I always marvel when I flip one over and I say, oh good, it's unmolested, because it won't present the almost unlimited number of problems that an amp like this will. Well, enough moaning and bitching. Let's get started and see if we can't make this thing work. Alright, now I'm working on the tube sockets. First, drain all the electrolytic capacitors, because otherwise you're going to reach into the plate socket hole right here while you're touching the body of the amp and get blasted across the room. Okay, so drain the filter caps, then you go in with a small screwdriver and reduce the interior diameter of all of the clips in here that will be holding the tube pins. Look to see if any of them are burnt or disfigured, and I guess then you'd have to replace either that pin or the entire socket. Okay, with the 12AX7s and 12AT7s, you can look in and see if the sockets appear to be intact. They do in this case, but they're very dirty. So next we'll clean them, then we'll insert the tube set and see if we've improved the performance any. Okay, the problems just keep piling up. I'm in the Vibrato channel. Listen to the erratic response to the clean, actually brand new volume pot. It just shifted to much higher volume. Also, look what happens to my current limiter as I crank up the volume, drawing a whole lot more current until at 10 it shuts off. I've never seen a pot act like that, not a brand new clean one. Very strange. Now let's watch here in the normal channel. I crank it up, goes away at 2, starts to increase at 3, and as the volume increases, so does the current draw by a tremendous amount in the normal channel. Again, I've never seen a pot behave like that, especially not a new one. Then check this. Let's turn on the bright switch. Well, there goes all our sound. I shudder to think, but I believe the bright switch is new too. God knows how it's been wired. Okay, through all this I have the master volume at 10. Otherwise, you get nothing. This is kind of interesting too. I'm going to increase and decrease the amplitude of the input signal and watch how it affects the current draw. Naturally, on a fixed bias amp, the harder you drive it, the more plate current you'll flow. But this seems extreme to me. Well, I removed the volume control pot that had been installed in the amp. It looks like a code 450. I'm not familiar with the manufacturer, but it's extremely cheaply made and has a real gravelly, rough rotation with no response until you turn the knob a quarter of an inch or so. Whatever this is, I absolutely don't recommend it. I installed an Alpha 1 meg pot here, which is no high dollar pot, but it feels like oil on glass compared to that other one. And now we have a nice uniform volume control. Now in the vibrato channel, the same problem exists. No volume control, like a little speed bump right there. So I'll replace this one now. And one unforeseen benefit is that the bright switch now works with the new pot. So two things fixed for the price of one. Okay, the second of these horrible potentiometers have been replaced here in the vibrato volume control. I've got the amp on standby. You can hear the input from the signal generator. Well, upon close inspection, and to no surprise, it appears that the wiring on the replaced pots is all screwed up. Let me give you an example here. Let's look at the base pot. Now, it's simply a variable resistor. In other words, the wiper has varying resistances to this lug. This lug is not connected. Now let's look at the base over here on the vibrato channel, and look what they've done. They've wired to the wrong lug. Okay, now I'm going to guess that a whole bunch of these are wired wrong, and I'm not going to bore you with going through it for about the next hour. I'm just going to correct the wiring then on these newly installed pots. Okay, I've corrected 4 different wiring errors committed during the installation of the new potentiometers. Now they're wired properly as per both the schematic and the layout diagram. As a result, the volume control now works in the vibrato channel, and the bright switch seems to function as a bright switch should. Now let's direct our attention at the removal of the master volume switch and pot. Okay, this is discussed on the internet a lot, but I could never find any clear, concise explanation of how to remove it. So let's go through the thought process involved to figure out how to remove this from the circuit and still have the circuit work at least as well, if not better. First, let's figure out how the pull, push, boost works. Now, a lot of you are familiar with boost pedals, which are like a little small amplifier that boosts the signal so that when it finally gets to the output tubes, it's much higher than it would be if it were left up to the amplification of the main circuit of the amplifier. Well, that's exactly how the boost works in one of these large twin reverbs and other similar amps that have the push-pull boost switch. And where it gets that amplified signal is actually very clever. I think a lot of you know that the reverb section in an amplifier circuit really is a separate amplifier. You run the signal through the 12AT7. Both triodes are hooked together at both the cathodes and the grids, and you feed what amounts to an output transformer, and that output transformer right here drives not a speaker like normal output transformers, but it will drive the reverb tank. Now, what if we were to take this boosted signal that is sent over here to what amounts to an output transformer, but instead of sending it down here to the reverb tank, what if we were to send it up to the grid of one of the amplification tubes? Don't you see that a very boosted signal then, which is the same as the music signal, would now arrive here and be much stronger than if it had just come through the regular amplification channels to get to this point. Okay, so, and that's exactly how they do it. When you pull for boost, you're simply sending the output from your reverb driver up into the amplification stages of your amp. Now this is going to be a cinch to get rid of. Let's simply, from this point right here, remove all of the wiring that connects it to the amplifier circuit. If we take this out, it will be like the boost switch is in a permanently off position. Now, what's wrong, you may ask, with having the boost switch connected? Well, the main thing is that the fidelity of the signal that is sent up here into the amplification circuit is not a particularly good quality. It, in effect, degrades the already amplified signal somewhat, and you end up with a more noisy, kind of trashy output that just happens to be real loud, okay, which is not a good combination. So by eliminating this, we're going to either be forced to just use the ungodly output of this amp as is, or buy a separate boost pedal that can create a high fidelity signal that will boost our output. Okay, so let's go ahead and simply remove this wire. Now there'll be 3 steps in the removal of the master volume control and push-pull boost. We'll have to remove this section here. Right up here we're going to have to remove this section, and we'll have to remove the potentiometer up here at the top. So let's start off with step 1, and I'll show you exactly where it's located in the chassis. Let's look at our landmarks. We've got a green wire, okay, going to our reverb tank, and we've got a 1K and 470K resistor. So from that point to that point, we want to remove it. We look up here and we see that here's the green wire to our reverb tank. We're going to cut this wire right here. This is the output to the reverb tank. And also we're going to come down right over here where we see the 470K and the 1K resistor, and we're going to cut this black wire. Okay, cut this and cut this, and we will eliminate stage 1 of the master volume control. Let me back away so you can see where that's located. Pretty close to the center of the board. Okay, and these 2 resistors are your landmarks. So let me get out the snippers. Okay, so now that black wire is removed from that junction, and the white wire is removed from the output jack to the reverb tank that has the green wire attached. Step 2 will be to remove this section right here, and our landmarks will be the 1 meg resistor and the 0.01 microfarad cap. Now we'll follow the remaining shielded cable down here to this point. And we see here is the 0.01 microfarad cap and the 1 meg resistor. So we're going to cut the signal wire right there, and we're going to cut where the shield is grounded right under here. Okay, snip, snip, and the signal then that would normally have come down here to be injected into the amplifier circuit will no longer be able to do so. Where's Jack? I see a tail, but I don't see Jack. Okay, the shield's been cut and the signal wire's been cut, and out it comes. Now we have completely removed the booster switch from the circuit. And also, to finish the cleanup after the removal of the shielded cable here in step number 2, we're going to remove the 12K resistor, the 0.01 microfarad cap, and the 1 meg resistor to ground. This is no longer needed. Now the reason that we have to eliminate these 3 components, the 12K resistor, 0.01 microfarad cap, 1 meg resistor, and of course the boost switch, is that this is a grounded line, and we do not want it to be able to interfere with the passage of our signal from the plate of V4B up here to the phase inverter. Okay, so we will eliminate that shortcut to ground to prevent it from interfering with the operation of our circuit. And as you can see, it no longer does exist. Everything's been cleanly removed from the circuit. Next, we will address the potentiometer here that controls the master volume. Now this part's going to be just a little bit trickier. Look right here and you'll see that we have our negative feedback loop coming in and going down to our long tail pair to feed into our 12AT7 phase inversion triodes. We don't want to affect it, okay? We want it to be able to come in here and down here, so that much has to stay intact. Then let's look at how the master volume control works. Look, we have the plate here of this, probably a 7025, goes through a coupling cap, 220K resistor. It comes up here, and a certain amount of it, depending on the position of the master volume control, will be fed into the grid of the phase inverter triodes. Okay, so what we'll do is when this wiper, or that little arrow, is all the way over to the left side, then all of the signal goes to the phase inverter. That's as if the master volume were set to 10. If that little arrow was all the way over here to the right, then it's as if the master volume was set at 0. So all we're going to do is eliminate the pot and this little kind of bypass cap right here, and we're simply going to wire from here to here. Okay, eliminating the potentiometer, eliminating this capacitor, and in effect leaving the master volume control at a setting of 10 all the time. So let's see exactly how we're going to do this. First off, the 120 picofarad cap is easy to get rid of because it's connected right to the pot. So when you remove the pot, you're removing the cap. No problem there. Next, we're going to look for the intersection of the two 220K resistors. And we're going to hardwire from that intersection over to the 0.01 microfarad cap. So it's going to be hardwired from here to here, and then this is gone. Our NFB loop remains intact, and this is gone. Let's take a look exactly how we're going to do this. Come over here and you see that There is the intersection of the 220K resistors, and right up here is the 0.01 microfarad cap. So all we're going to do is make a jumper between here and here. That's it. So now it's removed. You see that end was released here from this eyelet. This end down here came from that 220K junction, and there was a shield for the signal wire that was here to ground. So now the master volume control is completely removed from the circuit. But we're not quite done, because we have to put in a jumper from here to here. Let's do that. Okay, and there's our jumper from the 0.01 microfarad cap down here to the junction of the two 220K resistors. Now you're probably saying, great, that wasn't too bad, but now I've got a gaping hole in my control panel. So here's what I propose. What if we put a pot in here with one of these knobs and use it as a variable negative feedback control? What do you think of those potatoes? Here comes the negative feedback signal from the secondary of our output transformer down here through an 820 ohm 1 watt resistor, and then right into our long tail pair phase inverter, just like it does on the black phase and pre-master volume control Silverface amps. Now, to make it variable, we're going to come up with a combination of potentiometer and fixed resistor that will allow us to go way below this amount and way above this amount. The higher we go, we'll shut down the negative feedback. The lower we go, the more negative feedback we'll have. Okay, so let's look in the parts drawer and see what kind of potentiometers we have and how we can do this. Okay, my parts choices sometimes are predicated on what I have in stock, and I have a 10K linear pot, which is really going to shut down that NFB loop, and I've got a 470 ohm resistor to establish the maximum amount of negative feedback. Remember that originally we had an 820 ohm resistor, so this will allow much more of the negative feedback to come through than the 820 ohm resistor. So we'll go from higher negative feedback to much lower negative feedback depending on the setting of the pot. So instead of the NFB loop coming down here through a fixed 820 ohm resistor, we're going to have it come here through a 10K variable resistor out through the wiper, through the 470 ohm fixed resistor, and then on to the long tail pair. And since Fender thought it was important to put a 0.01 microfarad cap here in parallel with the resistance, we'll do the same. Okay, and then after all this is set up, we'll jumper it and see if it makes any difference. Okay, I like to experiment. Okay, now, so this is the way it's going to be set up. Let's install our parts and see how it looks. Now, looking at our eyelet board, we see here is the negative feedback resistor, gray, red, brown, 820 ohms with the parallel 0.01 microfarad cap that we saw in the schematic. Also, just to further verify it's the right one, you see the wire here comes from the speaker outlet as you would expect, okay, the secondary of the output transformer. Now, let's remove this resistor, and in that gap, let's wire in our negative feedback pot here with the fixed resistor in series. Now, when our pot is at 1, you'll have almost no negative feedback. Why? Because you've got the 10,000 ohms here plus your 470 ohms eliminating it. Then as you turn this up to 10, you're down here to 0 ohms, and so now the total net resistance in the NFB line is only the 470 ohm resistor that we just installed. So this is lower resistance, and this is much higher resistance than we had before. Therefore, the NFB loop is now variable. When testing the amp, it seemed to me that the reverb was a little weak when compared to other Fender reverbs, and I think I discovered the reason. If you look here at the 12AT7 that drives the reverb driver transformer and the output tank, you'll see that it has a 680 ohm bias resistor and no bypass cap, whereas on the one in the blackface circuit, the 12AT7 has a 2200 ohm resistor and a 25 at 25 bypass cap. So I think to pep up the output here of this 12AT7 to make it drive the reverb tank harder, we're going to put in a 25 at 25 cathode bypass cap on the cathode of the 12AT7. Okay, I've got the amp on here. The volume is about 1 3/4, which is about all I can stand. This thing is extremely powerful, very, very loud. Okay, so keep the volume moderate. We'll turn the reverb just to 5. Okay, now I do not have the bypass cap wired in. Let's hear before with no bypass cap. Hardly any reverb, really. Now let's go ahead and connect the bypass cap. Difference of night and day. I think it's a really good improvement, and it strengthens the reverb, so let's hardwire that in. Okay, for those of you then who want to spruce up the reverb on your master volume control Fender Silverfaces, here is the modification on the schematic. You see that we run a 25 microfarad at 25 volt bypass cap in parallel with the 680 bias resistor to ground. Let's look in the chassis here and see where it is. If you look in, we're right, let's see, that's V3 just down below, and you'll see here we have the blue, gray, brown 680 cathode bias resistor, and then we have our bypass cap here, positive end toward the tube, negative end down here to ground. Now the reverb is, I'd say, at least doubled in intensity. Alright, now we've gone from an amp in which absolutely nothing worked into an amp in which I believe everything works. And just to prove it, let's start and go down the line here and try every single adjustment and setting and see if it doesn't have the appropriate effect. Alright, the amp is on, we're in the normal channel, and the volume is set at 2. Let's try the treble off. Treble at 10. Wow, that was fun, huh? How about middle? I kind of like it with the middle turned up. Okay, and now the bass. Now the bright switch. Okay, so much for the normal channel. I think everything works great. Now let's try the vibrato. Okay, we got the volume set at 2, just like we did in the normal channel. Treble's at 5. Let's try treble at 10. Whoa, that hurt my fillings. Back down to 1. No treble. Only 5 or 6. Sounds about right. How about the middle? Now the bass. Wow. Jeez. enhanced reverb. We'll go to 6. And 10. Really too much. Down to say 5. Sounds about right to me. Now let's try the tremolo speed and intensity. Alright, now it's time for the tremolo, and I have created a little RCA plug that's shorted here. You have to have that type of jumper in place or a foot switch in place for the tremolo to work. Let's crank the intensity, say, to 5 and the speed to 5. Woo, nice. Boy, is that swampy, eh? So I would say both the intensity and speed seem to work just fine on the tremolo. And last but not least, we have the newly added adjustable negative feedback control. It's at a setting of 1, which means no negative feedback. That was minimum. This is maximum negative feedback. See how that negative feedback tames the higher frequencies especially, but really compresses everything down and kind of keeps it under control, keeps it cleaner, and pretty much eliminates any sort of distortion. Oh, and I almost forgot the all-important brightness switch on the vibrato channel. Here's without. And it definitely works. Well, I think we verified that all of the controls now work and that the amp is functioning very well. I think it's time now to turn it over to Jack and Ollie so they can really ring it out, and we'll see how it performs playing some hopefully familiar tunes. Looks like Casey's going to go over to her personal gym for a quick workout. Scratching post, quick chase by Jack, and back to the couch. Okay, we're out in the workshop here with the Ampro 50-watt Jensen ceramic speaker cabinet that I made and featured in earlier videos. And because it's only a 50-watt up against this monster of an amp here, we're going to have to keep the volume to sort of reasonable levels, okay? Not quite seismic levels. So Jack and Ollie are all ready to go, so let's play a few tunes. Okay, now we'll switch to the vibrato channel and ask Ollie and Jack to do a few tunes for Okay, let's try the reverb now. It's at a fairly conservative setting of 4. Now let's try the tremolo. We'll do it at 5 and 5 on the intensity and the speed. Well, I guess that about does it for this very lengthy video on the challenging repair of the 135 watt Fender Twin Reverb. I'm sorry that it let us down there at the last minute, but that's the way things go in the amp biz, and it'll just give us something to work on another day. Now I'd like to thank all my Patreon patrons and PayPal contributors for keeping us on the air and advertising free for another month. Any of you who would like to join them will please look in the video description for links that will enable you to do so. And I think it's time for Jack and me to jump in the old hot rod and take a spin in the country to rest up for our next video. So until we meet again on the sunny shores of YouTube land,